So hello guys, with the name of God Ram Ram, I am Kumar K. Today we are going to solve this 3100 plus rated problem 3166 build some problem of Codechef starters 175. It is a 7-star rated problem and like 40,000 people gave the contest. 40,000 people gave the contest and out of them only 5 to 8 people or 5 to 10 people were able to solve this question. That is the difficulty level of this particular problem. So let's start the enjoyment of solving this problem. This problem assumes that you should have all the knowledge. First of all, you can know about me. I have given lots of things about me here. You can read it up. The people who are new to our channel can go through these things to get all the important information. Okay. Now, if we come below guys, you need to have lots of bit manipulation and XOR based knowledge to solve this problem. So what is XOR? You should know about the XOR operations, right? Even though this problem is so tough that only 5 to 8 people could solve it in the world, still I will tell you what kind of thinking can lead you to the solution. So first of all, we start with understanding the XOR operation which we do on binary numbers. 1 XOR 0 is 1. 0 XOR 1, same as above, is 1. Whenever two numbers are same, na, two binary numbers are same, their XOR is 0. 0 XOR 0 0. And 1 XOR 1 is what? Think about it, 0. So whenever the two bits are different, it's 1. Whenever the two bits are different, it's 1. But whenever the two bits are same, it's 0. Whenever the two bits are same, it's 0. Generally, whenever the hard level coding question is given to you, it's involving bit manipulations or it's very good to convert. Most of the times it works out. All you have to do is convert the decimal number to binary and then start looking what is happening at a bit level in each particular column. That's why I've written it here also guys, that always convert the decimal number to binary. Always convert your decimal number to binary and solve each bit by bit. To solve this problem, you need very high level order thinking skills, but I will make you do it. Always have faith in God. Ram Ram. Because everything which you achieve in this life will always be through the energy and the power which you get from God. So, next thing, if I give you two decimal numbers and I ask you their XOR, you cannot tell their XOR directly. First, you calculate the binary version. 6 looks like if you don't know how to convert the decimal number to binary, you can just Google it up. Keep on dividing the number by 2 and whatever is the remainder, you keep on checking that. And depending on that, if the remainder is 0, then 0 or 1, then 1. Then it gets converted to binary. Why do we do binary numbers, by the way? Because, you know, all the electronic machines, computers, everything, even your AI at the fundamental level works on 1 and zeros only. 1 means, yes, the current went there. 0 means no current. Anyways, such a nice concept to enjoy. So guys, 6 looks like 100. Okay, 6 looks like this. And 8 looks like this. I'm adding an extra 0 at the start. You can append it. 8 looks like this. What will be the XOR of this? You do the XOR column wise, na, column wise. Always do things column wise. So 0 XOR 0 0, 1 XOR 0 1, 1 XOR 0 1, 0 XOR 1 1. So triple 10 is the answer. Now triple 10 you have to convert back to decimal to know the XOR of 6 or 8. So this is column number 0, column number 1, column number 2, column number 3. Whenever there is a 1, it contributes 2 raised to 1 to the answer. 2 raised to 1. This will contribute 2 raised to 2. And this is at column number 3. Now, if a 1 is at a column number 3, it means that particular 1 is going to contribute 2 raised to 3. 2 raised to 3. So the answer will be 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3, which is 8 plus 4, 12. 8 plus 4, 12. 12 plus 2, 14. 14 is the answer. 6 or 8 will be 14. Okay. Which is actually the summation also. So hopefully these concepts are clear to you. Now, if we go ahead, let's check out the question. The question is saying that you are given x1, x2, x3. Just make sure that the sum of x1 and x2 is x3. Guys. they will give us three integers. You can see in this question also that you will be given x1, x2, x3. You just have to make sure that x1 plus x2 become equal to x3 in the minimum number of operations. What is the operation? You can choose any number y, and on any two of these numbers you can do the XOR y operation. Such a nice problem. Lovely, lovely, lovely. And x1, x2, x3 can be anywhere from 0 to 10 raised to 9. You can see there are many test cases. So in log of x, max of x1, x2, x3, you'll have to solve it. Anyways, we know that the decimal number which is as big as 10 raised to 9 na, at max, the x1, x2, x3 given to us will be as big as 10 raised to 9, and 10 raised to 9 can be represented in binary. If I convert it to binary, it will look like this. So the length of this binary representation will be 30 at max. So you only need to travel 30 bits to solve the question somehow. If you travel the 30 bits, then per test case it will take 30 operations. So t into 30 should be the time complexity. How many test cases are there? You can see 2 into 10 raised to 5. So 2 into 10 raised to 5 to 30, 60 into 10 raised to 5, which is less than 10 raised to 8. So it will be able to solve the question in less than 1 second. Okay, less than equal to 1 second, whatever you want to say. So now they are saying that we are giving you x1, x2, x3. Please convert. In the 7-star problem, they are telling you that we are giving you x1, x2, x3. Please somehow make sure that x1 plus x2 become equal to x3. For this, you can pick up any two numbers and you can do them, change them. You can do XOR y on them. You can do XOR y on them. Then you can pick up any two numbers and you can again do XOR y on them. This y can keep on changing as per requirement. For example, let's take a simple example, right, for you people. Like given x1, x2, x3, make sure that these become equal. In one operation, you can select any two numbers and do first number equal to first number XOR y, second number equal to second number XOR y. Do these operations as many times as you want with different y, huh? Different y. This y can change. You can select y depending on your choice. It's her choice. Anyway, so x1 is 3. Jokes apart, jokes apart. Don't take it seriously. Oh, yeah. So guys, x1 3, x2 is 2, x3 is 1. Now you want that 3 plus 2 become equal to 1. Is it happening? No. So what will you do? I will do one special operation. In that particular operation, what I will do is I can choose any two numbers, right? And I can do them XOR y. So which y will I select? I will do them XOR with 3. Okay, I will select my y as 3. So guys, if I do 3 XOR 3, this number will become what? X1 will become 0. And if I do 2 XOR 3, what it will become? 2 XOR 3. 2 looks like this, right? And 3 looks like this, right? If you do the XOR, it will become 1. So guys, after doing that operation, I selected x1 and x2 and I did XOR y. Y was the number of my own choice. Okay, I should write it here that, like, I don't even need to write it here. You understand that in any one operation, you can select any two of these three numbers and you can do XOR y on them. Okay, that y will be your own y and this y can change in the subsequent operations. Okay. So the y can obviously change in the future. Okay. Depending on your needs, you might have to do more than one operation. So guys, if I do XOR y here, x1 becomes 0, x2 become 1. Now 0 plus 1 is equal to x3, which is 1. So in one operation, you were able to solve this question. But now guys, why were so many people not able to solve this question? We don't know no, how many operations do we need to do, guys, and which operations to do and how to do, we don't know. X1 comma x2 comma x3 is given to us. You might say, sir, first I will do this XOR y1 and this XOR y1. What is y1, sir? I don't know how to select. I will do something. Then, sir, I will do this XOR y2, this XOR y2. Then, sir, I will do x1 XOR y3 and this current x3 XOR y3. Then, sir, I will do x2 XOR y4 and x3 XOR y4. You can randomly do any number of operations, right? How will they lead to the answer? People could not see it. The biggest observation is that, guys, only three operations are needed. Only three operations are needed. At max. And this simplifies the whole freaking problem. Now, why is this the case? I will tell you. Either you do the operation on the, see, this is the first number, second number, third number, okay? Either you do the operation on the first and second number, and then you can do the operation on first and third number, and then second and third number. Why? Either your operation, guys, will be on the first and second number, or you can try to do the operation on first and third number or second and third number. But guys, someone can say, na sir, why can you not do multiple operations on first and second? You can say, na sir, first I will do both these number, I will do their XOR with y1. Then both these numbers I will do their XOR with y2. Like this can also happen, na sir? I say no. Why? If you are first, what you are doing x1 XOR y1 and x2 XOR y1. So now the updated x1 is x1 XOR y1 and the updated x2 is x2 XOR y1. Then you are saying, sir, I am doing y2 also on both these numbers. Okay, now you do y2 on them. How these two numbers will look like? x1 XOR y1 XOR y2. x2 XOR y1 XOR y2. This could be achieved in one operation also. You did two operations here. This could be achieved in just one operation. Just club the values of y1 and y2. Instead of doing XOR y1 to both of them, then doing XOR y2 to both of them, you can just do x1 XOR y1 XOR y2, x2 XOR y1 XOR y2. Oh my goodness. So basically कहने का मतलब ये है कि एक ही पैर पे मल्टीपल टाइम ऑपरेशन करने की जरूरत नहीं है. अगर मुझे x1 x2 पे ऑपरेशन करना है ना, तो एक फाइनल नंबर z डिसाइड कर लो और x1 को z से जोर कर लो, x2 को z से जोर कर लो. अब बस इसके बाद दूसरा और करने की जरूरत नहीं है. क्यों? बिकॉज z यू कैन सिलेक्ट एज y1 और y2. तो आपका y1 वाला भी इन दोनों को जोर हो जाएगा, y2 वाला भी इन दोनों को जोर हो जाएगा और दोनों जुड़ भी जाएंगे अगर इसके अंदर जोर डाल दिया तो समझो, लेट्स से समवन कम्स एंड टेल्स यू दैट ब्रो, I want to do three operations on x1 and x2. First, I want to do both of them XOR y1. Then I want to do both of them XOR y2. Then I want to do both of them XOR y3. You will say, hey bro, rather than doing three operations, I will just do both of them XOR d. I will do both of them XOR d, where d is nothing but y1 XOR y2 XOR y3. This will generate the same effect as doing three operations on this pair. So guys, the question is now easy. It is guaranteed that you can just do one smart operation on this particular pair. Similarly, you can just do one smart operation in this particular pair and one smart operation on this particular pair. So only three possible operations are possible. Now, three possible operations are there. Now you need to decide where to do operations and how to do the operations. So the first three thing is clear to us, okay? Now, this thing is clear, right? x1 was 3, x2 was 2, x3 was 1. The output came as 1. In one operation, you could do x1s or x3, x2s or x3 and this. But the thing is that in three operations, the task can get done at max. This was explained in the video, okay? So guys, first let us try the operation wants y1. Then the second operation wants y2. and the third operation wants y3. Whole thing can be done in just two operations also. Oh my goodness. Oh my goodness. Now guys, the next analysis for the 7-star problem is that you can do the things which can be achieved in three operations can be achieved in two operations also. Okay? You can say that, sir, I want to do 1 comma 2 operation. I want to do XOR Z on 1 comma on 1 comma on I want to do XOR Z1 on 1 comma 3. I want to do XOR Z5, okay, or XOR Z3. So let's see the cumulative effect, the final effect. On the first and second number, you want to do XOR Z, right? So it will look like what? X1 XOR Z, X2 XOR Z. On 1 and 3, you want to do XOR Z3. So this will look like X3 XOR Z3. And here one more. X first number is also getting done with Z3, right? So Z3. 2 and 3, I want to do Z1. So here Z1 will be added in the XOR sum. And here also Z1 will be added in the XOR sum. Okay. These things are clear to you. So basically what you want, that finally X1 value should become this. X2 value should become this. X3 should become this. This can be done in just two operations. Rather than using three operations, you can achieve the final task in two operations also. Because finally you want these two values only. So guys, in the first operation, you will smartly do something on X1 and X2. What you will do? In the first operation, I will just do the operation on the first and second number. I will do both of them XOR with which number? You can manipulate and find it out, okay? You can just do some smart manipulations and find it out. And you can achieve the same result as before, okay? You will do the XOR on these two numbers and then you will do the XOR on these two numbers. Got it? And the same effect can be achieved. But you will have to do the thing smartly. Like you can say that, sir, on the first and second number, I will do the XOR of Z XOR Z3. Z XOR Z3 I will do. So X1 will become what? X1 XOR Z XOR Z3. And X2 will become what? X2 XOR Z XOR Z3. Okay. Now guys, I will do the operation on 2 comma 3. On 2 comma 3, what I will do? On the third one, I will do Z3 XOR Z1. So it will become Z3 Z1. You can see X3 XOR Z3 XOR Z1. And third and second both Z3 XOR Z1. So guys, X2 is now looking like this. If you do Z3 XOR Z1 on it, Z3 will get cancelled and Z1 will be clubbed. It will look like X2 XOR Z XOR Z1. It is the same as which you wanted. In just two operations, you are able to do it. Oh my goodness. So we understood this also. Such a deep problem it is, right? First you come to know that three operations are enough. Then you come to know that the work of three operations can be done in two operations also. We want the minimum number of operations. So guys, which cases are there? First you will try to do everything in zero operation. Then I will try to do the things in one operation. Zero operation is easy, right? Then I will try to do the things in zero operations. If you are not able to do in zero operations, you will try for only one operation. If not able to do for in one operation, then I will try to do for two operations. And not able to do for two operations, then the answer is -1, not possible. Only 0, 1, 2 are the possible operations possible on these three numbers. Because you never need three or more than three operations. Zero operation का case is very easy, guys. राम राम. Zero operation मतलब कोई operation करने की जरूरत ही नहीं है. वो कब करोगे? Guys, if x1 plus x2 is already equal to, then you need to do zero operation ना. कुछ मत करो, equal ही है. Now guys, let's try to analyze first the case of one operation and then we will analyze the case for two operations. Okay. So guys, x1, x2, x3 is given to you. You want to analyze the case where you only do one operation. So you have many choices, right? Sir, one operation I can either do on first number and second number, or second number third number, or first number third number. We will have to analyze three cases separately. First, let's analyze the case when we try to do the one operation on first number, second number, and we try to make it equal to the third number. Okay. Once we have solved the case for first number, second number, then we'll try to solve the case for second number, third number, first number, third number. Okay. So let's try to do it, baby. Let's try the enjoyment. So life is very interesting. See, our lovely students recently cracked Apple offer than offer from Flipkart. You can, check it. My students have given me lots of happiness. Okay, you guys can check it out here. Really lovely. Anyways, now I come here in Flipkart also. Student cracked off-campus offer, so very happy about it. I am very happy. Fills me with joy and proud. Okay, you can watch some Flipkart videos also. Now, guys, it's the time to enjoy. So, guys, now if I go below, you understood that the whole thing can be done in two operations also. So, it's only three options: zero operation, one operation, two operation. Zero operation case is simple, right? If the numbers are, if the sum of x1, x2 is already x3, answer is zero. Let's try for one operation. If you fail to do in one operation, then we'll try for two operation. Okay. The nice thing about this problem is that once you understand the hard level solution for one operation, you can just use your brain and little bit thinking and you can solve for two operations. So that will be homework for you. And first we will try the case for doing one operation only on 1 comma 2. Once you are able to do the one operation on 1 comma 2, then you same technique you can apply for 1 comma 3 and 2 comma 3. Now guys, forget everything. Just think that you want to make x1 plus x2 quantity equal to x3 by doing only one operation on the pair 1 comma 2. So you only think which number should you do their XOR with y such that their sum become equal to x3. Think about it. The best trick is, guys, that convert the x1 and x2 numbers in binary and solve them bit by bit. So guys, listen to me carefully. Let's try to do it in one operation. Let us try to do the operation on the first number and the second number, and let's try to make x1 plus x2 equal to x3. Okay, so guys, there can be maximum 30 bits only, right? So if for this case I'm showing you only the bit number 4 to bit number 0, or bit number 0 to 4. So let's say that the first number x1 is 6, second number x2 is nothing but 13. We want their sum to be equal to x3, which is 11. And this is fourth bit, third bit, second bit, first bit, zeroth bit. 6 looks like what in binary? 6 looks like 0, 0, 1, 0. 0, 0, 1, 1, 0. And 0, 1, 1, 0, 1 is the 13 representation. Now guys, you only think. Whenever a 1 is coming, you want to make this sum. What is this sum? This sum is x1 plus x2. You want to make this sum equal to 11. But guys, do you know what is happening whenever a 1 is coming? A 1 is there here at the first position. It means it is contributing 2 raised to 1 to this sum. A 1 is there at this position. It means contributing 2 raised to 2. A 1 is here. It means it's contributing 2 raised to 0. A 1 is here. It means it's contributing 2 raised to 2. A 1 is here. It means it's contributing 2 raised to 3. If you do the whole sum of this, it will come out as 6 plus 13, which is 19. So hopefully you understood that when a 1 is there, it contributes 2 raised to I, where I is the column number. Okay. Now guys, you have to do both of them XOR Y. You have to do both of them XOR Y. Which Y to choose? The trick is try to solve one column at a time. Try to solve one column at a time. So guys, let's say I focus on this column, okay? I focus on column number 3. Okay, only this column. I can see that here there is a 0. Here there is a 1. If I XOR both of them with a number which is looking like this, such that other numbers are not getting affected. Other numbers are not getting affected. Only a 1 is there here. What is going to happen? This 0 will change to 1. Because 1 XOR 0 will be 1, and this 1 XOR 1 will become 0. This will become 0. So what has happened? Earlier they were looking like 0 1. Now they are looking like 1 0. But the sum remained the same. Earlier this guy was contributing 2 raised to 3. Now this guy is contributing 2 raised to 3. So guys, the biggest observation is that you should never do a XOR operation of 1 on a column which is having 0 and 1 both, because they only get reversed. What I'm trying to say is that on this particular column, if I try to XOR both these numbers with 1, nothing will happen. This 0 will become 1 and this 1 will become 0. So they just got reversed. This 1 0, this 0 1, after doing a XOR operation of 1 on both of them, it just became 1 and 0. The sum earlier was also, this was contributing 2 raised to 3, now also contributing 2 raised to 3. So what's the use of this? So you should never do an operation on a column where 0 and 1 is there. So guys, which columns have zeros and ones? Never do operation here, it's not no use. Never do operation here, no use. No use. But guys, what if both are ones and both are zeros? Here both are ones. Obviously, if I do the operation with 0 on both of them, nothing is gonna happen, right? There will remain same. But if I do an operation with 1, both the ones will become 0. Both the ones will become 0. So earlier the guys which were 1 will become 0. So you can just calculate. This is what? 2 raised to 2. So this was also contributing 2 raised to 2. This was also contributing 2 raised to 2. So 2 raised to 2 is 4. 4 plus 4, 8. You can subtract 8 from the total sum, because 1 1 is becoming 0 0. So total 8 ka loss ho gaya na. You can calculate the net loss possible. So a loss of -8 is possible. So basically in 6 plus 13, you can do -8 if you want. So guys, what is 6 plus 13? 6 plus 13 is 19. You can do -8. If you do -8, it will become 11. Oh my god, we reached our goal. How to make it 11, guys? You know that if two ones are there, they can become 0, right? These two ones can become 0. How they can become 0? You need to do an operation of XOR 1 with them. So I will XOR both these bits by 1. So 1 will be here. Rest of the columns I don't want to change. So 0, 0, 0 there. So guys, this will be my y. If I XOR with this y, this number will become 0, this 0, and this sum is nothing but 11 actually. So basically you come to know by this method that if two ones are like this there, they can become 0 0. A loss of 2 times 2 raised to I is possible. Loss of 8 is possible here, okay? But guys, we can gain also something. If both the numbers are 0, and if I do a XOR of 1 on them, well, this will also become 1, this will also become 1. Just the reverse. The 0 zeros can become 1 1. So a gain is also possible. A gain of 2 raised to 4 here and 2 raised to 4 here. So 2 raised to 4 times 2. 32 gain is possible. So guys, it's simple. What will you do? You will just travel both of these binary numbers from bit number 0 to bit number it can go till bit number 30. Okay, but for the small example, I'm only going till bit number 4. Whenever both the bits are different, don't do anything, because if you do any XOR operation, they will just get reversed. If both bits are 1, you can calculate the total loss possible. You can remove both of them by doing 2 raised to 2 2 times. And if both are 0, you can do the addition. So whatever loss and profit is possible, now put them in a change array. Okay. So guys, you can see that for this particular example, if you consider the bit number 2, you can do a loss of -8. If you see a bit number 4, you can do a loss of gain of 32. So these are the changes possible on x1 plus x2. Now your task is that use these changes to reach your final goal. How will you use these changes to reach your final goal, guys? Simple. Numbers from here can be used with original sum to reach x3. Try all possible subsets of this change array. अरे हमको ये पता चल गया है, ये जो दो नंबर्स है ना, हमको पता चल गया इनमें क्या क्या चेंजेस हो सकते हैं. समझो वो सारे चेंजेस मैंने एक एरे में डाल दिए. या तो इसमें -8 हो सकता है, या तो +32 हो सकता है, या ऐसा कुछ कुछ हो सकता है. सो यू हैव टू सिलेक्ट अ सबसेट फ्रॉम हियर such that where x1 plus x2 plus subset becomes equal to x3. ऐसा सबसेट उठाओ कि जब वो x1 x2 में ऐड हो तो x3 आ जाए. सो बेसिकली यू वांट टू फाइंड अ सबसेट सच दैट सबसेट इज इक्वल टू x3 minus x1 plus x2. So that's it, guys. I can write it here also. Try to find subset such that subset is equal to x3 minus x1 plus x2. There can be many up and down cases. You should handle it. Okay, positive, negative. Okay, but guys, finding all the subsets of the array can be a costly task, right? There can be 30 elements in the changes array because there are 30 bits. So 2 raised to 30 it will take to do the backtracking and generate all subset sums of the change array. क्योंकि चेंजेस एरे में जो जो है हमको सारे टेक्निक्स ट्राई करने पड़ सकते हैं. अभी अभी फिलहाल के लिए चेंज एरे बहुत छोटा है, तुम देख रहे हो. Only -8 32. Sir, either I can do -8 or I can do 32 or I can do -8 plus 32. I can apply both the changes na. I will do the XOR operation here of 1 and XOR operation here of 1. Rest others will remain 0 and this will become my y. Y will be 1 0 1 0 0 0. In this case, this will gain plus 32 and this will gain -8. So either I can get a -8 or I can get 32 or I can get -8 plus 32 or I can get empty subset. Do no change. So total 4 subsets are possible. 2 raised to 2. So if this change array size is 30, it can raise to 2 raised to 30 subsets possible. So in general case, you will try all subsets. But guys, there is an easy way to directly get to your desired goal. This easy way, I will explain it in this video itself, guys. Okay. What is the greedy method, guys? The greedy method is very, very interesting. You will love it. The greedy method is that you know the total sum is 6 plus 13, right? Now, whenever you see a loss, subtract the loss immediately. So guys, I know 6 plus 13 is what? 19, okay? I see that a loss is possible here. Loss of what? Loss of 2 raised to 2 2 times, 4 times. So 2 raised to 2 4. 4 into 2 8. 8 times, sorry. I changed my previous statement. 8 loss of 8 is possible. And here a gain of 32 is possible. So loss of 8 is possible. So just do 19 minus 8. It will become what? 11. Okay. But whenever you see a gain, don't do anything. Now make a change array. Now the change array will look like 32 comma 8, not -8, plus 8. Why? Now my x1 plus x2 is equal to 11. Why? because I assumed that whenever the loss case was there na, I just subtracted it, so no loss is possible. देखो यहाँ पर 1 1 है ना, तो मेरे को पता है कि मैं इसको इसको मैं लॉस कर सकता हूं, तो पहले ही मैंने उसको अपने में घटा लिया। मैंने अपने मन में इन दोनों को जीरो कर लिया है, कर लिया मैंने जीरो इन दोनों को, तो इनका सम 11 ही आएगा ना, कर लिया जीरो। तो अब क्या केस बनता है, अब ये केस बनता है कि अब ये दो जीरो है तो इन दोनों को 1 किया जा सकता है, अब इन दोनों को 8 का प्रॉफिट हो सकता है और इन दोनों को 32 का प्रॉफिट हो सकता है। अब जब 32 वाला प्रॉफिट चूज करोगे ना, तो जोर ऑपरेशन यहां पर करना पड़ेगा, पर अगर 8 का ऑपरेशन चूज करोगे तो कुछ करना ही नहीं पड़ेगा। क्यों? क्योंकि तुमने अभी अभी -8 किया था ना, तो +8 करोगे तो नल इफेक्ट हो जाएगा और ये चीज अपने आप इंक्लूड भी हो जाएगी। Got it? So this makes the case very very interesting, guys. Okay, let's take a final example and you will understand how subtracting in advance is making things so easy, because now your changes array will have only positive elements. Trick is to subtract. Trick is to subtract initially all loss given, then changes array will have only positive elements which are power of 2. It's very easy to find subset sum if changes array only have positive power of 2. Such a deep question it is, right? Deserves to be a 7-star problem, guys. So now, my lovely people, what I'm trying to say is, let's take this example which was given to us in the question itself, right? So if we go below, yeah, 3 2 1, right? 3 2 1. 3 looks like what? 2 looks like this. And you want to become 1, right? This is bit number 0, bit number 1, bit number 2. The changes array looks like what? You will say, okay sir, 1 0, I will not do anything. 1 1, sir, I can do a loss here of 2 raised to 1, which is 2 times 2, 4. I can do -4 here. But this is not a good change array. Negative numbers ruin the changes array. So first I calculate the sum. What is the sum? The original sum which we can see is 3 plus 2, 5. Now whenever I see a loss, now I will just subtract the loss immediately. So guys, if you come here, what loss can you see? I can see I can do a loss here. I can do a loss of 4 here. So I will do 5 minus 4, which is what? 1. So now, and let's say our goal was not 1. Okay, let's say our goal was something very interesting. Our goal was, let's say guys, let me think a bit. Our goal was, let's say 9. We wanted to become 9. Okay. So I saw a loss here. I subtracted 5 minus 4, 1. Okay. And I can see here a gain is possible. A gain of what? A gain of 2 raised to 2 times 2, which is 2 raised to 2, 4, 4 into 2, 8. So now my changes array will look like this. Here a gain of 8 is possible. And here a loss, no, now a loss is not possible because loss I have already done. I have already made these guys 0 in my mind. So loss is already done. So now only gain can happen here. If I do operation again, which will be silly actually, but no problem. Now a gain of 2 raised to 1 into 2, 4. Gain of 4 is possible. Now guys, these are your elements in the changes array, which if you represent it as power of 2, it looks like this. 2 raised to 3 and 2 raised to 2. What is your current number? Now my current sum, basically whenever I see a loss, I subtract it from the sum so that my changes array only have positive numbers. Now my sum is 1 and I want to become what? 9. I want to become 9. I want to become 9. Okay. And what is the difference? Difference is 8. Whatever is the difference, it will always be a power of 2 for sure. It will always be a power of 2. Okay. This is like it will not always be a power of 2, but it will be some number, right? It will be some number. Whatever is that number, you represent it as a power of you represent it as a power of 2, guys. Okay, you basically whatever it is a number now, you represent it in binary, and that binary will be, if it those binary representation is available in changes array, then you can solve it. Okay, so in this case the difference is what? Difference is 8. Convert it to binary. 1 0 0 0 0 1 2 3. So yeah, you want a 1 at position 3, and convert this changes array also in binary. 1 triple 0, and then this is 1 double 0, like this only. The changes of array will have only positive powers of 2. So by looking at this, you can see you want 1 triple 0 and 1 triple 0 is available, problem solved. But let's say the change, let's say it was a very hard case. Let's say the what I require is this number 1 0 1 0 0 0 0, and the changes array look like this. Changes array, it will always be a power of 2, so it will always look like this only. Power of 2 always look like a 1 and then all zeros, 1 and all zeros, 1 and all zeros. So how will you know if it is possible to reach this via this? The thing is that this requires what? 1 0 0 0. First you try to find this number 1 and 1 2 3 4 times 0. Is it there? Yes. Then you try to find this 1 and all zeros. Yes. It means if you choose this and add them, this will come. This was the trick. So hopefully guys, you really enjoyed this problem. And the same thing, guys, the thing is that we are doing give and take, right? So first you try this algorithm on first and second number for one operation. If it does not work out, then you try on first and third number and second and third number. This is a homework for you. On first and third and second and third, no, same trick works, but the only thing is that here the 0 1 alternate is important rather than the 1 1 and 0 0. Okay, once the one operation things are done, guys, the third case comes for two operations, and guys, then the whole problem is solved. Okay, so it's a homework exercise for you, but don't worry, I will add the notes for the harder cases also. And when you do all of this, guys, you deserve to be a 3100 plus rated coder on Codechef. You have broken all the limits. So with the name of God, Ram Ram.